Welcome to the mathematics class, students. Let us discuss the topic indefinite integrals session 1. And the aim of this session is to define the integral and the process of integration. And from the definition of process of integration, we'll derive some formula as basic formulae. Those basic formulae are also called as the standard integrals. And we'll find out the related problems to the basic formulae. Let us switch on to the theory part of what is an integral. Let us define a derivative of a function capital F of x as small f of x, where capital F of x being the derivable function in terms of x, it is a derivable function of x. So d by dx of capital F of x is small f of x. Implies we can say this f of x as the derivative of capital F of x. Then how can you speak capital F of x with respect to small f of x? Capital F of x is called as the antiderivative. It is called as antiderivative of small f of x, and this also been known as integral, and which can be denoted as using elongated s. We'll find out elongated s before that function which you call it as antiderivative, whose antiderivative is this, before that function whose antiderivative is this, and dx stands for the variable of integration, which leads as capital F of x plus c. So in this the constants are, this is a symbol of integration, this is called integrand, it is a variable of integration, this is called integral, this is called constant of integration. The first one is called as symbol of integration, symbol of integration. The second one is called as integrand, the function which you are going to find integral. This is called variable of integration, with respect to which variable you are finding the integral. And this is what is called integral. And this is called as constant of integration. Why specifically constant of integration is defined? Because if you take capital F of x plus c along with and find the derivative, and as f of x is derivable function, d by dx of f of x is defined, whereas d by dx of a constant, from the definition this will become 0, so you will be getting only f dash of x as the derivative of f of x, but this is 0. So when you are finding the integral, that constant may not appear, and that will reflect in its integral. So whichever you will find out the integrand, that integrand will be existing along with its integral and the constant, which call it as constant of integration. Observe that the process of integration is almost the reverse process of differentiation. So reverse process of differentiation is nothing but integration. Before we discuss about this topic, let us find what are the algebraic properties related with the integration. There are two algebraic properties as we had in the case of functions or functional algebraic properties and limits algebraic properties. Here we have algebraic properties of integration, as if at all we take f of x and g of x, these are integrable functions. Integrable. So when do you say function is integrable? If its derivatives, these are being their derivatives are existing, so we can say that they are integrable functions. Then first property is integral of f plus or minus g of x dx can be taken as integral of f of x dx plus or minus integral of g of x dx. Next, second one, if any function is multiplied with the constant, that is k of f, where k is being a scalar, that is a real number, then integral of k f of x dx is equals to k times of f of x dx. This is second property. And third one is, if at all integral is say function of some ax plus b dx, then this can be exhibited with f of ax plus b by a plus c. This is of course as a part of formula we'll treat in the standard form. So these are the properties of indefinite integration. Now let us switch on to the how come integration being the inverse process of differentiation and the connected basic formulae. Like as we have seen that when d by dx of capital F of x is taken as small f of x, implies we say integral of f of x dx where this will be the integrand and this will give you as capital F of x plus c as its integral, and c being the integration constant. So what you are finding is whenever there is a derivable function and its derivative is existing, this is its derivative and it is the function. So this function, what you call it as antiderivative, and this antiderivative only you are calling it as integral. So the process of integration is to find the integral. We can define the process of integration very simply that, so finding the integral for given function, this is what is the definition, basically the process of integration. But how you are finding the integral? You are finding the integral such that the derivative of that particular integral is given function. So integration is a process of, we can simply say, finding that function whose derivative is given function. So it will be given with some function and that function will be the derivative of the function what you are going to find. So finally we conclude that this integration, the process of integration is nothing but the reverse process of differentiation. So integration is a process where you will find reciprocal process of differentiation. So since integration as the inverse process of differentiation, based on this concept will derive all the integrals, that implies all basic formulae, they will exist from definition of integration. As definition of integration is the inverse process or reverse process of differentiation, unless you have the derivative existing for that function, so you cannot find integral. So based on this one, if f of x derivative is small f of x, then the integral of f of x is capital F of x. Like for example, you can say simply d by dx of sine function, derivative of sine function is cos of x. Employees, we can simply say integral of cos x as derivative with respect to x will be sine of x plus some constant. So unless the derivative exists, we cannot write its integral. So based on this process, let us find out all basic formulae in this way. The basic formulae will begin with very first one. Number one is, if at all d by dx of x to the power of n plus 1 by n plus 1, where being n plus 1 is constant, and if you find its derivative, it is n plus 1 times of x power n plus 1 minus 1, n plus 1 gets away, leaves it as x power n. So we can find out then integral of x to the power of n dx will be is equals to x power n plus 1 by n plus 1 as c, where c being the integration constant. This will be the very first basic formula of integration. Next, second one is, if d by dx of log of mod of x will be is equals to 1 by x, then integral of 1 by x dx will be is equals to log of mod of x plus c. This is second one. Next, number 3, if d by dx of e to the power of x is e power x, then integral of e power x dx is equals to e power x plus c. This is third basic formula. Number 4, if d by dx of a power x is a power x times of log a, then integral of a power x dx is equals to a power x by log of a plus c. This is fourth one. Next, fifth one is, if d by dx of sine of x trigonometric function, that is cos of x, then integral of cos of x dx is equals to sine of x plus c. Sixth one, if d by dx of cos of x dx is equals to minus sine of x, then integral of sine of x dx is equals to minus of cos x plus c. Next, seventh one, if d by dx of tan of x dx is equals to secant square x, then integral of secant square x dx is equals to tan of x plus c. Next, if d by dx of cosecant x dx is equals to minus cosecant x cot x, then integral of cosecant x cot x dx is equals to minus of cosecant x plus c. Ninth one, if d by dx of secant x is secant x tan x, then integral of secant x tan x dx is equals to secant x plus c. Next, tenth one is, if d by dx of cot of x is equals to minus cosecant square x, then integral of cosecant square x dx is equals to minus of cot of x plus c. Next 11th one is, if d by dx of sine inverse of x is 1 by root 1 minus x square, then integral of 1 by root 1 minus x square dx is sine inverse of x plus c, or we can say integral of minus of 1 by root 1 minus x square dx is obviously cos inverse of x plus c. So with the difference of negative sign we can find out both integrals. Now 12th one is, if d by dx of tan inverse of x is 1 by 1 plus x square, then integral of 1 by 1 plus x square dx is equals to tan inverse of x plus c, or integral of minus 1 by 1 plus x square dx is cot inverse of x plus c. This both you can write. Now the last one is, if d by dx of secant inverse of x is 1 by mod x into root of x square minus 1, then we can say integral of 1 by mod of x root over x square minus 1 dx in terms of secant inverse of x plus c, or else minus of cosecant inverse of x plus c accordingly. So these are all the standard integrals based on the definition of integration. The definition of integration is a reverse process of differentiation. Using derivatives we can find out all these basic formulae. Next, let us switch on to the examples related to this basic formulae. Example number 1. Evaluate integral 1 plus cos 4x by cot x minus tan x. Now integral 1 plus cos of 4x by cot of x minus tan of x can be written as integral of 1 plus cos 2a. 1 plus cos 2a in terms of cos is 2 cos square a. Using this trigonometric identity, I can write this as 2 into cos square 4x by 2 is 2x divided by, if I write cot as 1 by tan, that is 1 minus tan square x by tan x. Finally, integral of this is 2 cos square 2x by, if I multiply divide by 2, therefore 2 into this is 1 minus tan square x by 2 tan x. This 2 gets cancelled. Integral of this is cos square 2x by this is cot of 2x, because this is 1 minus tan square x by 2 tan x, you can write it as 2 tan x by 1 minus tan square in the denominator is 1 by tan 2x will become cot 2x. So if you can find out cos by sin, that is cos square 2x by cot 2x as cot of 2x by sin comes to the numerator sin of 2x, this is dx. Here the variable of integration. Now here cos 2x goes once, leaves you sin 2x, cos 2x with the same angle, then multiply divide by 2, then it will become 2 sin 2x into cos of 2x dx. This implies 1 by 2 into 2 sin a cos a, that is 2 sin a cos a is equal to sin of 2a. Using this identity, 2 sin 2x cos 2x will become integral of sin of 4x dx. Therefore, using integral of f of ax plus b, that is capital F of ax plus b by a, this is a, therefore integral of sin is cos of 4x by a, that is 4 plus c, therefore minus 1 by 8 times of cos 4x plus c will be the correct answer for this question. Next, let us go to the example number 2. Evaluate the integral 1 by sin square cos square. Obvious that I is equals to integral of multiply divide by 4, as there is sin square x and cos square x dx. Therefore 4 is outside, integral 1 by this 4 become 2 square, so that become 2 into sin of x cos of x whole square dx, that is 4 into integral of 1 by 2 sin x cos x will be sin 2x, hence it is sin square 2x dx. 4 into integral of sin square, we can write it as cosecant square 2x dx. Therefore I is equals to 4 times of integral cosecant square 2x. Again it is in the form of f of ax plus b. So it is a standard integral. Integral of cosecant square x is minus cot of 2x by 2 plus c. Therefore to become minus 2 cot 2x plus c will be the answer for this question. Next, let us go to example number 3. Evaluate integral cos 4x cos 7x product. So here this is based on the formula, that is 2 into cos A cos B can be written as cos of A plus B plus cos of A minus B. So using trigonometric transformations, let us take cos of 4x cos of 7x as half times of 2 cos of 7x cos of 4x. Thereby it can be written as half times of 2 cos 7x cos 4x is cos of A plus B plus cos of A minus B. Therefore integral of cos of 4x into cos of 7x dx can be written as integral of half times of cos of 11x plus cos of 3x dx. If I separate using algebraic property, half times of integral cos of 11x dx plus half times of integral cos of 3x dx. Again it is in the form of f of ax plus b. Integral of cos is plus sine 11x by 11 plus half times of integral of cos is sine 3x by 3 plus constant. Finally it becomes the form of sine of 11x by 22 plus sine of 3x by 6 plus c will be this is the correct answer for this question. Next let us go to the example number 4, that integral of 1 by root of ax plus b minus root of ax plus c. As it is a irrational quantity, let us go for rationalization. Multiply, divide by its irrational quantity, that is ax plus b plus root of ax plus c by root of ax plus b plus root of ax plus c dx. That implies integral numerator is root of ax plus b plus root of ax plus c by this is ax plus b minus ax minus c dx. Employs here ax cancels away b minus c. 1 by b minus c stands as constant. Root of ax plus b dx minus integral of root of ax plus c dx equal to 1 by b minus c, and integral of root ax plus c, which we can write x power 1 by 2, then it is ax plus b to the power of 1 by 2 plus 1 by 1 by 2 plus 1 using x power n plus 1 form. But as it is in the form of ax plus b, by a you will get, and minus of this is ax plus c to the power of 1 by 2 plus 1 by 1 by 2 plus 1, and by a comes. So finally this can become 1 by, here a is common, into b minus c, and here 1 by 2 plus 1 is 3 by 2, which is in the denominator, comes to the numerator become 2 by 3. So 2 by 3 times of a into b minus c of ax plus b to the power of 3 by 2 minus ax plus c to the power of 3 by 2. This is the correct answer for this question. Next let us go to the example 5. Evaluate the integral cos of 2x plus 2 sin square x by cos square x. Integral of cos of 2x plus 2 sin square x by cos square x dx. That is, if I expand cos 2x in terms of sin square as 1 minus 2 sin square x plus 2 sin square x by, that is cos square x dx, employs integral of 1 by cos square of x dx, that is integral of secant square x dx, which is standard, that is secant square x integral is tan of x plus c.